Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar, Service Solutions to Modernize Electrical Assets. My name is Megan Purdy and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them and their cultures and to elders past and present. Before we get started, I would like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, ABB. ABB is a leading global technology company that energises the transformation of society and industry to achieve a more productive, sustainable future. By connecting software to its electrification, robotics, automation and motion portfolio, ABB pushes the boundaries of technology to drive performance to new levels. With a history of excellence stretching back more than 130 years, ABB's success is driven by about 110,000 talented employees in over 100 countries. Now, we have a rich discussion planned for today, starting with a joint presentation to set the scene. We'll then follow that with two presentations and our audience Q&A. So I encourage you all to please send your questions through to our speakers via the chat box. To begin, I'd like to introduce our co-presenters who will be setting the scene for today's discussion. Please join me in welcoming David Montefano and Matteo Arioldi. David is an electrical engineer with nearly 2 decades of experience in the medium voltage sector, focusing on circuit breaker retrofits and replacements. He currently serves as Global Product Manager for MV Circuit Breakers Retrofits and Replacement within the Electrification Service Division at ABB Italy, based in Bergamo. In his global role, David drives product strategy and innovation, supporting customers and upgrading and extending the life of their electrical assets through advanced retrofit solutions. His work contributes to safer, more efficient and sustainable power distribution systems worldwide. Joining him is Matteo Arioldi, the Global Product Manager at ABB Italy. Matteo has an extensive experience in low voltage retrofit solutions, helping customers extend the life cycle of their electrical assets while improving safety, reliability and sustainability. In his role, Matteo leads the global strategy and development of retrofit kits for low voltage air circuit breakers, enabling modernization of existing installations without the need for full systems replacements. His work focuses on delivering innovative, cost-effective and environmentally conscious solutions that support the transition to a more sustainable electrical infrastructures. Please join me in welcoming David and Matteo.
Okay, thanks a lot for the introduction. Good afternoon, everyone. Let's start with the presentation. Speaking about modernization service in ABB, our target is definitely unlock access potential with a solution that is efficient, reliable, definitely safe, reducing the total cost of ownership. And our target is to extend the lifetime of old asset about 20-30 years. We have different business area in the modernization team. First one is extension, upgrade, and retrofit. In this area, we want to update up to now with the latest standard, the original asset that is obsolete. Also, we have another area that is replacement. So whenever you have equipment that is running and you want to replace it with the same technology or something improves, is in our replacement solution. At the end, we also have the end-of-life services that we can handle properly in the right way, also considering to the sustainability and the environmental rules of your country, the end of life of the equipment. Now, let's start to speak about the typical pain that our customer can have on their installed base. Starting from the first one, aging infrastructure. Now it's quite common that you can have equipment in your system that are outdated, so it means that they are in service for more than 30 years and they already reached the end of the life. So you need to modernize them. This is linked to the budget constraint because, as you know, the full replacement of an old system costs a lot of money, and a lot of customer and sector, for instance, utility, also they have a very high demand to increase their energy handling. So it means they have to build new infrastructure. So this is very linked to very tight budget to do all these activities. And safety compliance definitely is a must. As for ABB, a lot of customers, they have target for safety, and to be a compliance with the latest standard is a target for a lot of customers and reduce definitely the accident. Also, we have to consider the obsolescence of the component. When a component go to obsolete, maybe the spare parts are no more available. This means that the managing, maintenance, and handling can become a nightmare for the customer. And it is linked to high operational cost. Handling an obsolete product, maybe with whole technique and technology, have a very high total cost of ownership of the product that make the operational cost very high. Let's speak also about sustainability goals. Like we have in ABB, a lot of customers today, they're starting to have a target of reducing their environmental impact for the society. And the last one, that one is one of the most important, is to avoid downtime risk. Because for a lot of sector, downtime is not an option, and definitely they want to keep uptime as maximum as possible. Now let's have a look about our solution, the Retrofit solution, ABB, part of the modernization portfolio, and how we can give value considering the typical pain that customer has. First one is the life extension. Our solution are certified to have 30 years life extension. Also about the budget, typical retrofit, you can save up to 50% of the capex compared to the full switchgear replacement. So definitely it's very important for when you have a budget constraint and you need to do a lot of modernization activity for your plant. Safety, I said, with the ABB retrofit, you are going to have the latest version of the standard, so we enhance safety according to the latest version. And you are putting in all system new active product. So it means that you have a product with the full availability of spare parts, and also speaking about operational cost, you can save up to 40% of operational cost due to the lower maintenance you required, lower cost of spare parts, and faster procedure to handle an active product compared to the obsolete one. Speaking about sustainability goals, is proof that adopt a retrofitting compared to the full switch replacement, you can save up to 80% of CO2 equivalent compared to the full switchgear replacement. And of course, the retrofitting is very high reliability solution compared to the old one. So you can really dramatically reduce the risk of downtime. Now, I hand over to Matteo speaking about the typical retrofit technique, and after that, also more details about our retrofit solution. Matteo, to you.
Let's now explore the three main retrofit techniques available for circuit breakers. These solutions are essential for extending the life of existing switchgear installations, improving safety, and ensuring compliance with modern standards without the need for a complete system overhaul. Retrofitting is a strategic approach that allows us to modernize electrical systems while minimizing downtime, cost, and environmental impact. At ABB, we've developed a comprehensive portfolio of retrofit solutions to meet the diverse needs of industrial, commercial, and infrastructure applications. The first technique is direct replacement. This is the most straightforward and time-efficient solution. It involves replacing the old circuit breaker with a new one that is mechanically and electrically compatible with the existing cradle. The key benefits are device compatibility. The new breaker is designed to match the original dimension and interfaces, ensuring a seamless fit. Quick installation, since no structural modifications are needed, the replacement can often be completed in just a few hours. And logic perseveration. Existing control wiring, interlocks, and auxiliary circuits remain untouched, which reduces the risk of wiring errors and simplifies commissioning. This solution is ideal for installations where downtime must be minimized, such as data centers, hospitals, or continuous process industries. The second technique is the hard bus retrofit. In low voltage, this involves a new breaker with a custom design adaptation system that connects to the existing bus bars. In medium voltage, this same concept is known as one fit, a standardized retrofit solution that ensures compatibility across a wide range of legacy panels. This method is used when a direct replacement is not feasible, perhaps due to the obsolete components or non-standard configurations. The advantages include use of a standard device, which simplifies future maintenance and ensures long-term availability of spare parts. Enhanced safety, because the new breaker brings modern protection features such as advanced electronic trip units, arc fault detection, and remote monitoring capabilities. And structure preservation. The original switchgear panel remains in place, avoiding the need for civil work or major rewiring. The third technique is cradle in cradle. This technique introduces a new frame enclosure inside the 61, allowing the installation of a modern breaker. While it's a valid option for low voltage systems, it is not commonly used for medium voltage applications due to the different mechanical and dimensional constraints. The benefits are, again, the use of a standard device, which ensures compatibility with ABB current product portfolio, enhanced safety thanks to improved insulation, arc containment, and the possibility of integrating digital diagnostics, and easy of installation. There is no need to disassemble the fixed part of the old circuit breaker, and the new breaker can be installed quickly. As shown in the diagrams, the color-coded legend helps visualize the scope of each installation. Each of these techniques is backed by ABB's engineering expertise, rigorous testing, and global service network. They are designed to ensure electrical continuity, reduce operational risk, and support the transition to smarter, more sustainable power systems. In conclusion, ABB's retrofit portfolio offers a flexible, safe, and cost-effective path to modernize aging infrastructure. Whether you're looking for a quick swap, a tailored adaptation, or a full compartment upgrade, there's a solution that fits your technical and operational needs, helping you meet today's demand while preparing for tomorrow's challenges. This slide highlights one of ABB key strengths, our comprehensive end-to-end expertise across the entire value chain. At ABB, we don't just assemble retrofit solutions. We design, engineer, and manufacture every critical component of the retrofit in-house. It all starts in our product factory within the Smart Power and Distribution Solution divisions, where we produce the core technology that power our solutions. Take medium voltage, for example. We are the original technology manufacturer of vacuum interrupters, medium voltage poles, and circuit breakers or contactors. These components have been developed and refined over more than 100 years to ensure we remain at the forefront of innovation and performance. The same philosophy applies to low voltage. Our factory manufactures the breakers we use in our retrofit solutions. This vertical integration guarantees perfect compatibility and long-term reliability, something that's critical in retrofit applications. Our primary service centers are over 30 years of retrofit experiences transformed into tailored solutions for our customers' installations. Here, we manage the full process, from designing retrofit kits for ABB, legacy ABB brands, and also non-ABB install base, to validating them against international standards, producing them, and performing routine tests before field installation. Consider that we are qualifying our retrofit also for nuclear power plant for 1E applications. This deep technical know-how gives us the full control over the quality and performance of the final solution, ensuring that what we deliver is not only reliable, but also engineered to last. Let's now take a closer look at the 4 pillars that define our retrofit offering, each one designed to bring your electrical infrastructure to the next level of performance. Flexible, because our retrofit solutions are designed to extend the lifespan of existing switchgear. Safe, because safety is not negotiable in electrical system. Sustainable, because in today's society, sustainability is becoming one of the key pillars and a primary goal for most customers, just as it is for us at ABB. And smart. Our retrofits are not just mechanical, they are digital. Together, these 4 pillars, flexible, safe, sustainable, and smart, make ABB's retrofit offering a future-ready solution that delivers measurable value across performance, cost, and environmental impact. Now, let's go in the details of each pillar. So, next to you, Davide.
Thanks, Matteo. Okay, now these slides provide a deeper look for the first pillar of our retrofit, that is flexible, cost-effective, extended lifespan. It's a concept that brings together long-term reliability, financial efficiency, and operational flexibility. Key priorities for every organization managing aging electrical infrastructure. Let's start now with the first part, that is life extension. As I said also before, our retrofit are engineered and designed to last 30 years lifetime extension. So mean when we apply our retrofit old system, we can extend the full life of old system about 30 years because the part that remain is just the copper and the steel of the switchgear that definitely can last much longer than 30 years. So we are just replacing the part that is at the end of the line, the outdated part that is the breakers and the retrofitting of the relays. Second point is the OPEX reduction. So here we want really to boost efficiency and cut cost about the old system. We did the real case study and also study with the university to calculate the total cost of ownership of a retrofitting compared to keeping the obsolete product in service. And we found out that normal case is giving 1/3 reduction in the OPEX during the lifetime. So this means that the return of investment of a retrofit project is much shorter than having the full switchgear replacement as a modernization solution. The other part is the capex saving. We also make a study that considering the turnkey project of modernization using full switchgear replacement compared retrofitting, we can save up to 50%. In the key project, of course, we are considering everything. Also, the typical civil works that you need to do when you want to replace the full switchgears instead of applying a retrofit project. Let's go to the last one, is a fast installation. Definitely, retrofitting allow a very fast installation commissioning that is up to 90% less than the typical full switchgear replacement. Because normally, a retrofitting in 1-2 hours, you can install and commission it compared to 10-20 hours per panel when you do the full switchgear replacement. Also, since you are not changing like the medium voltage cable and the low voltage connection, you are also avoiding the typical unplanned cost that you are having when you do the full switchgear replacement. We met customer that doing the full switchgear replacement at the end, due to unplanned cost, civil works, problem with the medium voltage cable, they end up to 4 times the cost higher than the price of the switchgear. And definitely this is very painful for our customer. Having a cost not planned is definitely a problem. Now let's go to the second slide and the second pillars of our value proposition. that is definitely safe and reliable usage of our retrofitting. First pillar is to reduce operator risk. Like in ABB, a lot of customers, they have a target to reduce the accident for their operators to zero. So applying a retrofitting that is a new technology updated to the latest standard reduce a lot the problem of a failure having the operator working on the product. Also, to be aligned to the latest standard definitely improve a lot the reduction of the risk compared to the past. An option that is available for some specific design of our retrofit is also applying operation from remote. Typically, rack in, rack out of the breaker from remote and opening, close the breaker from remote. This is really reduced drastically or eliminate the risk for operator because they avoid human error in doing the operation. And of course, if something happens, the operator will not be in front of the panel. This is really a very high improvement for the safety for the operator in the plant. Go to the next one, high reliable product. Of course, if you want to modernize all the system, you need to apply a solution with high reliability. This is proven by the mean time between failure, typically of our breaker. We're using, as explained before, technology that we are own in our factories, the very, very low mean time between failure. This is proof so the high reliability of our solution. And especially because our solution are certified performance according to the latest standard. As you can see here in the slide, there are the standard that we use and apply in our label of the breaker in order to prove the value that we put in the label. So it means that the nominal current that we put, the short circuit withstand, the electric performance, and the interlocks are fully aligned with the standard requirement. This is also make a distinction because our retrofit is not just done with very expert technician, but everything that is in the label is fully proofed. And this is the typical solution that you can find also in the market that is called repair as a retrofitting. That means that it's just a mechanical adaptation of a breaker to the system. So even if it's done in the perfect way, it's not possible to prove and guarantee the performance of the solution. Last point, of course, we want to eliminate hazardous, both for technician and for the environmental. For instance, medium voltage, now we are adopting vacuum technology that for ABB is called VD4, that is full SF6-free solution. So we want to eliminate SF6 from the installation if it's required. Also, we are eliminated outdated component that 40 years ago was possible to use that can be an hazardous for the operator, like asbestos in some case, or also for environmental, like oil circuit breaker, take out the oil from the breakers. Now I hand over again to Matteo.
Sustainability is a core value in ABB's retrofit strategy, and this pillar is where we make a real difference. Retrofitting has a significantly lower environmental footprint. Compared to producing and installing a new switchgear, our retrofit solutions reduce environmental impact by up to 80%, avoiding around 4 tons of CO2 equivalent per unit. That's roughly the same as 2 economy round-trip flights from London to New York. We maximize the use of existing materials. ABB retrofit solutions are designed to maximize the reuse of existing components like metal enclosure and bus bars whenever feasible, helping reduce costs and minimize downtime. This avoids wasting around 1 ton of raw materials per panel, making retrofitting both efficient and responsible. Our designs are not just sustainable, they are certified. We provide environmental product declaration, EPDs, for our retrofit solution, verified by third parties to ensure full transparency and credibility. And we take care of what comes next. Our Take Back program ensures that outdated electrical equipment like circuit breakers and switchgear is properly collected and recycled in full compliance with local regulations. In short, ABB retrofit are not only a smart technical choice, they are a responsible environmental one. Let's now look at pillar number 4, advanced digital integration, a key enabler for modernizing electrical systems through retrofit. By integrating digital sensors and smart solutions into our retrofit design, we can improve operational and maintenance efficiency by up to 60%. This means faster diagnostic, better monitoring, and more reliable performance. Traditional maintenance strategies, waiting for equipment to fail, can be up to 10 times more costly and environmentally damaging. With our digital tools, we shift to condition-based maintenance, reducing service time and extending intervals by 30%, while keeping system healthier for longer. Electrical failures can cause serious disruptions, financial losses, reputational damage, and even penalties. Our digital retrofit solutions help reduce unexpected outages by up to 30%, ensuring smoother operation and higher reliability. Finally, retrofit is the perfect opportunity to digitally upgrade your switchgear. Replacing old relays and installing smart sensors allows data collection and integration with ABB's cloud-based platform. Through our Power Care agreements, asset managements become proactive, customizable, and future-ready. In short, digital integration transforms retrofit from a simple upgrade into a strategic investment in performance, reliability, and sustainability. And now, over to you, Davide.
Thanks, Matteo. Now let's spend some minutes to go more in details about some key elements about sustainability. First point that already mentioned in the slide before is EPD, Environmental Product Declaration. As anticipated, there are different types of EPDs. Mainly the difference is if are self-verified and certified or certified by third party. As ABB, we define that our EPD are only type 3, so means verified by third parties according to specific standard. This is very important for us because make a very clear value to our customer because it's standardized, and also internally we can use these EPDs in order to improve our design, giving specific target of improvement. So let's start with the global standard. We use two operator, EPD Norge for medium voltage and PEP EcoPassport for the low voltage. And we are today the only company that are doing EPDs for retrofit solution. I said this is very important because when in the past, the typical target when you design a retrofit is the operational target that you have to reach and minimize the cost. Now, having the EPDs also, we put a new target in the designing that is environmental value. So in our R&D team, they have to meet the standard, the performance required, trying to reduce the cost, but optimizing the environmental impact of our product. Okay, so using EPDs, so we also make specific case study for customer. In this case, we have a customer in Sweden that is having installed an old obsolete ASEA Safe6 medium voltage switchgear. ASEA is a legacy brand of ABB that ASEA with Bramboveri became ABB. This switchgear is quite small switchgear that is composed by one incoming 1250 amps and four outgoing unit 630, and is 20 years old. Customers starting to face the typical problem that we also introduced before, and they want to modernize their system. And they have the typical two options, or the full switchgear replacement, so buy new switchgear and take out the old one and replace everything, or adopting a retrofitting project. In this case, so we compare the value of our EPD type 3, so certified by third party, in terms of material usage and kilogram of CO2 equivalent. So let's focus now on the materials. So we use the EPDs of ABB medium voltage switchgear having the same rating on the top, And on the bottom, with VD4 HPA, is our EPDs of retrofitting for the same panel. We compare the material, so the quantity of plastic, copper, other metal, the typical steel, other miscellaneous that you can find in the panel, and the packaging, the typical is food. And you can see highlighted the delta, so the difference adopting a new switchgear compared to the retrofitting. For instance, you are saving 158 kilogram of plastic, 278 kilogram of copper, 2,573 kilogram of mainly steels, and the other 423 kilogram of others, and 558 kilogram of wood. This means that the total saving, so you can avoid to produce and use raw material for around 4,000 kilograms. Or in another way, considering the old structure very similar to the new one, you can keep and give a new life to 4,000 kilograms of raw material produced in the past with very big impact for its footprint for longer time than the typical 30 years, but for other 30 years. Also, EPDs give the equivalent in kilogram of CO2 of different stage of the lifetime. You can see here that, for instance, we have the manufacturing, so the impact of manufacturing, starting from the suppliers, the production of the product, the distribution, the installation, and the end of the life. Since here we are comparing two solutions, we are not considering another stage that the usage for 20 years that is required in EPDs. Because when we make some calculation and test, the typical value of losing the contact resistance of old switchgear and the retrofit compared to new switchgear and new breaker are very similar, because we're using the same port, same technology, same similar quantity of copper. So we are not comparing now the usage because we consider equivalent. So comparing manufacturing, distribution, installation, end of life, we end up with a value of 1925 kilogram of CO2 equivalent avoided adopting retrofitting. As before, we also use typical conversion. Okay, we use a website to give the conversion. In this case, for this customer, we make the equivalent using conventional petrol car. So it means that only for 5 panels is like using a petrol car for 133,000 kilometers around the planet. So it's very huge impact in sustainability adopting retrofit, and is proof with EPDs. Now I hand over again to Matteos.
Thanks, Davide. Now I would like to walk you through the evolution of ABB SACE low voltage circuit breakers, both air circuit breakers and molded case circuit breakers, as shown in this timeline. Let's start from the top row, which highlights the history of our ACBs. It all began in 1961 with Automax, followed by Novomax G30 in 1970 and Novomax in 1980. These early models laid the foundation for reliable air circuit breaker technology. In the 1990s, Megamax introduced higher performance and modularity, while Emax in 1996 brought advanced protection and monitoring capabilities. The evolution continued with new Emax in 2004, which introduced better integration. And finally, in 2013, Emax 2 revolutionized the market by combining protection, control, and energy management in a single device, becoming the world's first smart breaker. Now, looking at the bottom row, we see the development of our MCCBs. Starting with ISOL in 1956, ABB introduced compact and robust solutions for molded case protection. Fusel in 1965 added fuse-based safety, while Module in 1970 brought modularity. In 1980, Limitor improved performance and protection features. Then came Isomax in 1993, a milestone in MCCB design, followed by T-Max T in 2000, which introduced compact dimensions. Finally, T-Max XT in 2009 brought digitalization, connectivity, and high precision, making it ideal for modern energy management systems. This timeline reflects ABB's commitment to innovation, safety, and sustainability. Whether through new installations or retrofit solutions, ABB ensures that customers can rely on cutting-edge technology while extending the life of their existing system. Then, following the acquisition of GE Industrial Solutions, ABB made a strong commitment to support the installed base of GE low-voltage circuit breakers, not only by continuing to offer high-quality products, but also by developing retrofit solutions for every breaker in the GE portfolio. As you can see in this slide, the top row showcases the evolution of GE's air circuit breakers, starting from the early AK and AKR models through Power Brake, WEF Pro, and Impact Plus, all the way to Power Brake 2 and the more recent IntelliGuard L and IntelliGuard G. Each of these models played a key role in shaping the market over the decades. But GE's legacy doesn't stop there. The bottom row highlights circuit breakers from other brands that were acquired by GE over time, including AEG, Jack Alstom, Unilec, and Apena. Models like ME00, 05, and 07, Impact MK1, Spectronic S, and DS represent a diverse and complex installed base across different regions and industries. ABB has worked intensively to develop retrofit kits for all these breakers, ensuring that customers can upgrade their systems with minimal disruption while improving safety, reliability, and performance. These retrofit solutions are designed to be plug and play, preserving the original switchgear while integrating ABB's latest technologies. This approach reflects ABB's broader strategy to support legacy systems with future-ready solutions, enabling customers to modernize without replacing entire infrastructures. It's a sustainable, cost-effective way to extend the life of critical assets, and it's part of our commitment to delivering value beyond the product. Thanks a lot.
Thank you very much, David and Matteo, for your insightful presentation. Now it's my pleasure to introduce our next speaker, Danny Mayer, ABB Australia. Danny has been active in the electrical transmission and distribution industry since 1994, starting his electrical network planning for a major utility. He holds a bachelor's degree in electrical engineering and has joined ABB in 2006, initially focusing on substation design and construction. In 2012, he transitioned into the electrification service business, where he has since led service operations across high voltage, transformer, medium voltage, and low voltage segments. His core responsibility has been in marketing and sales, first in South Africa and since 2023 in Australia. Please join me in welcoming Danny Mayer.
Picture this. It's a typical day and you responsible for the electrical operations. Your substation feeds Heathrow Airport, the busiest airport in the UK. You've reviewed the reports, conducted your routine checks, and everything seems to be in order. For now. Deep down you know that the electrical infrastructure is aging and there have been warning signs. Minor fluctuations, occasional alarms, that seems like nothing serious. There's just no capital to replace the equipment. Now, let's fast forward to the 21st of March 2025. It's early morning and suddenly the alarm starts blaring. You rush to the control room and your heart sinks as you see the power grid flickering. Within moments, chaos erupts. The fire at the substation spreads rapidly and you realize the entire airport is about to be plunged in darkness. As the operations manager, the weight of responsibility bears down on you. You know that this outage will lead to the cancellation of 1,300 flights, impacting 200,000 passengers. The financial implications are staggering. an estimated loss of $26 million per day, not to mention the countless indirect costs that will ripple through the aviation industry and local businesses. In this moment, you understand the true cost of ignoring the warning signs. The consequences of not modernizing and maintaining the electrical infrastructure are now clear. The incident serves as a stark reminder of the importance of vigilance and proactive management in our operations. Today, as we delve deeper into the lessons learned from this incident, let's explore how we can ensure that our electrical systems are resilient, reliable, and equipped to support the demands of modern operations. Together, we can prevent disruptions from occurring into the future. Let's now turn our attention to how ABB can help avoid similar disruptions in future. At ABB, we recognize that aging infrastructure poses a serious risk to operational reliability and safety. That's why we've developed a comprehensive service portfolio with ABB Navigate standing as the cornerstone of our advisory capabilities. ABB Navigate is designed to empower our customers by providing them with the insights that they need to understand the current condition of the electrical infrastructure. Through detailed assessment, we evaluate the life cycle of the equipment, ensuring that you have a clear picture of its performance and reliability. Our team of experts collaborates with you to identify potential safety risks and operational challenges associated with the aged infrastructure. We don't just stop at identifying issues. We work with you to map out a strategic plan to address these challenges head on. This proactive approach not only enhances the reliability of your system, but also contributes to a safer and a more efficient operational environment. By leveraging ABB Navigate, you can make informed decisions that will extend the life of your assets, optimizing performance, and ultimately safeguarding your operations against unforeseen disruptions. Together, we can build resilient infrastructure that meets the demands of today and prepares for the challenges of tomorrow. Today, the ABB team will outline the available modernization possibilities.
Thank you, Danny, for your input. I'd now like to welcome our fourth speaker, Deepak Thakur from Electrification Services Australia. Deepak has over 15 years of experience at ABB with a strong background in product management, leadership, and a deep passion for the low and medium voltage service portfolio. He holds a bachelor's degree in electrical engineering and has completed management studies at the Indian Institute of Management. Deepak is dedicated to redefining the value proposition of service solutions by leveraging digitalization, sustainability, and safety. He champions solutions that enable the seamless integration of modern protection technologies into existing legacy systems, tailored to the unique needs of each customer. Please join me in welcoming Deepak Thakur.
Thank you. We are proud to highlight our local success stories in Australia. The solutions presented today are already in action across some of the most demanding industries and utility segments. The first success story is from oil and gas industry. The customer here is having 40 years old MNS2 low voltage switchgear with obsolete intelligent systems and air circuit breakers. This has increased the risk of failure and revenue loss, adversely affecting operational reliability. Spares unavailability and communication issues have further risked the system performance. In order to have the right solution at ABB, our modernization team did the site visit to understand customer challenges in depth and prepared a solution recommendation and architecture with new digital offering and Emax 2 circuit breakers. This has provided the latest protection and communication features. The solution brings a strong commitment to sustainability with increasing the life cycle of existing switchgear without major structural changes, reducing electronic wastage, and has improved efficiency. The new solution enhances availability with actively supported latest products, seamless integration to existing communication system, and that is supported by spares, training, and local expertise. Strong local ABB support by ABB modernization team and industry know-how has contributed us to be a valued partner with customer. Within our modernization portfolio, we have not only upgraded switchgears, but also have modernized legacy protection systems to build improved arc flash protection. The case shared here is from pulp and paper industry. The customer has 25 years old legacy switchgear. The existing switchgear lacked internal arc classification rating, which has increased the risk to personnel and equipment. This has made the immediate upgrade necessary to introduce arc flash protection. To develop the right solution, our modernization team did the site visit to understand customer challenges and prepare a solution recommendation with Rec 640 relays and arc flash solutions. This has brought a lot of reliability for customer. The upgrade to the Rec 640 protection relay has significantly enhanced the advanced diagnostics, real-time monitoring, and self-testing capabilities. This has minimized the risk of unexpected failures. The Rec 640 also supports advanced fault analysis, event logging, enabling proactive safety measures and compliance with modern electrical safety standards. Safety is significantly improved with the inclusion of arc flash protection system. The sensors detect arc flash conditions in milliseconds and trigger the proactive actions required to isolate faults, protecting personnel and equipment. The Rec 640 also supports advanced fault analysis and event logging, which enables proactive and predictive maintenance measures and compliance with modern safety standards. Modernization of protection system supports sustainability goals by extending the life cycle of existing infrastructure. The system's ability to integrate with smart grid technologies and support predictive maintenance also contributes to more sustainable operations by minimizing resource consumption and optimizing asset utilization. I believe our strong local ABB presence, expertise, and industry know how is our major strength. Thank you.
Thanks so much, Deepak. Well, now it's you, our audience's turn to get involved. Now, unfortunately, Danny and Davide are unable to join us for the Q&A, but who I would like to welcome is Amir Abbas, Global Product Manager, ABB, who will be joining us today. Now, before I start off with the questions, so just a reminder to the audience, please submit your questions via the chat box. Don't forget to let me know who your question is directed to. And a big thank you to everyone who submitted questions while registering today. Now, Amir, you've joined us for the Q&A, so I'll throw the first question to you to get you part of the conversation. This one's come in from a Raj in South Australia. And the question was, how can organisations strike a balance between the initial cost of modernising electrical assets and the long-term benefits, such as improved efficiency, reduced carbon emissions, and extended asset life? So that was the first question. And he then had a follow-up around, are there any new technologies that would make the modernisation process more cost-effective?
Yeah, thanks, Megan, and thanks, Iraj, for this question. Let me answer briefly about this clarification of this question from your side. So actually, organization can strike this balance by adopting the step-by-step retrofit strategies instead of the full replacement of the switchgear or of the whole asset. Because actually this allows the prioritization of the critical assets while spreading the investment over the time. Because ABB retrofits actually, as mentioned by Matteo and Davida, can offer up to 50% on the capex saving, inclusive of not only the material, but the shutdown, civil and manpower costs compared to the whole replacement of the switchgear. And actually emerging technologies like digital monitoring and condition-based maintenance and EPD certified retrofit solutions further enhance cost effectiveness and sustainability. And it's important to highlight that while keeping outdated equipment, often more than 30 to 40 years old in service, may help to avoid the initial cost of modernization. Statistically, these units have a failure rate between 1 to 5% per year. In contrast, new breakers typically have a failure rate between 0.01 and 0.1%. ABB offers a range of solutions to modernize these systems carefully, balancing cost and performance. These are the tailor-made operations and designed to advise customer on a case-by-case basis, helping them to identify the best investment by considering key factors such as safety, reliability, and long-term operation and sustainability.
Awesome. Thank you so much, Mia. Amir, while I have you, sorry, I will keep you going and then I'll start to bring everyone else in. And I can see the live questions coming through. So just for our speakers, I might pull some of the live questions in after this one. But the next question came through from Agus, who is watching in Victoria. And it was around, can the instrumentation data automatically feed into asset management systems? Good question.
Thanks, Agus. Absolutely, yes. ABB retrofit solutions can be integrated with any of the asset management system, adding sensors on the retrofit solution itself or on the switchgear. And through our platform, which is called ABB Ability Asset Manager, instrumentation can be automatically collected and analyzed and used our predictive maintenance dashboards, improving the reliability and reducing the shutdown interventions.
Awesome. Thank you. Matteo, I might pose a question for you. It's come through live to our audience. And just a bit of a heads up, we've got a very international range of speakers, but also we've got a lot of people from outside of Australia also watching today. So the first live question that I thought I'd pose to you, Matteo, was around the ability for this, if the retrofit is applicable to all switchgear or just ABB?
Yeah, let me say, we are developing our retrofit kits according to the latest standards and considering all the type of switchgear, not only ABB, because luckily the newer breakers that we are using for developing our retrofits are usually smaller compared to the old breakers. So it allows us to install the new retrofit without any issue in any type of switchgear. And also, when we are developing our retrofit kits, we are considering the modification of the door panel. So we are giving in each and every retrofit that we are developing a door adaptation kit that allow the customer to adjust the door without completely changing it. So at the end, our retrofit are available for any type of switchgear.
Awesome, thank you. Deepak, I was wanting to ask a question which came through from Anthony, who is watching from South Australia. And the question was, how can switchgear retrofits be undertaken considering requirements for verification of boards when modified as per Australian Standard 61439? Get Deepak. No, we don't have Deepak. He's actually... How are you going, Deepak? Got sound?
Can you hear me now?
We can. Did you want me to go through that question again, or are you okay?
No, I'm fine.
Awesome.
So I would repeat. Thanks. Thanks, Anthony, for the question. First of all, I would say that we have deep expertise about AS 61439 locally in ABB Australia Modernization team. If you look into AS 61439, it emulates closely IEC 61439 in terms of the criteria that have been nominated for compliance, whether it is temperature rise or short circuit withstand or clearances. So there are 9 items which needs to be complied in order to have AS 61439 compliant switchgear. For our direct replacement solution, which Matteo presented, we don't have any major deviation from AS 61439 because there are no major structural changes in bus bar, in chassis. So, but when it comes to a hard bus retrofit, we modify a bus bar. So we can't confirm unless we do a proper investigation of the switchgear on site and its conditions. So our modernization portfolio and advisory portfolio, they complement each other in that way. We can visit the site, look into the condition of the switchgear, and then make a report of what are the major deviations, if at all it is, from 61439, and then provide the solution from our retrofit replacement landscape from ABB. I hope it answers
Awesome.
that question.
Thanks a lot, Deepak. Well, I might have another question for you. It's come through from Namal in Western Australia, and I suppose it's with regards to, the case studies and how are you able to identify a problem with an end user that your solution can solve with minimal end user involvement?
Thanks, Nimal, for the question. So we have ABB condition monitoring solutions and digital portfolio, which enables us to do remote monitoring and predict failures without major manual intervention on site or in substations. So when we say about condition monitoring solutions, we have ABB condition monitoring edge device, which is utilized to enable real-time monitoring and management of electrical distribution systems. This also entails and covers motor control centers in a broad way for 415 volts. These edge devices often integrate into low voltage switchgear or motor control centers like MNS and collect data from sensors and intelligent devices, allowing predictive maintenance, optimize operations, and reduce downtime. When we talk about condition monitoring, there is on-premise condition monitoring that is available with our edge device. CMS, this device provides the monitoring platform, allowing users to access and manage the electrical systems via computers, tablets, and smartphones. So, in short, these are the solutions that we have, digital frameworks that we have. We can develop the architecture for the edge device, what kind of upgrade it is required, and that reduces the manual intervention or the end user involvement to a larger degree. ABB is able to monitor the condition and is able to recommend what are the proactive or predictive steps required in order to further extend the life cycle of the switchgear.
Awesome. Thank you
Thank you.
so much, Deepak. Matteo, we had a question which came through live, and it was from Pankaj, who said, "What do you mean exactly by low carbon retrofit? How does this work?"
Yeah, we are calling our solution low carbon retrofit for mainly two reasons. As explained by my colleague Davide before, we are developing our solution according and considering all the sustainability performance of our retrofit. So at the end, as explained in the case study by Davide, if we are using our retrofit to substitute an old equipment inside the switchgear, we are mainly saving a lot of carbon. So the carbon footprint of our solution is a lot less compared to substituting a complete switchgear. And also, another important thing is the EPD certification. We said in the webinar before, we are the only manufacturer that is having EPDs for certified by third parties for our retrofit kits. And retrofit EPDs are certifying that your retrofit has a certain carbon footprint, and thanks to the EPD, we are able to work and to improve the design of our retrofit in order to reduce more the carbon footprint of our retrofit solution. So this type of certification is allowing us to improve also our performance in terms of sustainability on the specific retrofit.
Thank you. Amir, there was a question which came through from Sebastian in New South Wales, and it was, is there a limit to how many times something can be retrofitted before a replacement is needed? Oh, on mute as well.
Sorry, Megan. Yeah. So
Oh,
actually,
good.
retrofitting can extend the lifetime of any switchgear by up to maybe 30 years. And basically, the structural components such as the copper and the sheet steel frames of any switchgear can last even more than 30 years. So, however, when a core element like the enclosures and the bus bars begin to degrade and maybe deteriorate, by the time a full replacement may become necessary. While this means retrofitting is typically applicable only once or twice during the total lifetime of the whole switchgear. And EPB applied this concept even in critical infrastructure, such as nuclear power plants when qualified 1E retrofitting is essential. And in order to ensure the safe and reliable long-term operation. And we evaluate each case to ensure safety and reliable performance of the existing asset as well.
Thank you for that. Now, I've just lost my track of where I'm at with my questions. So numbers, I was thinking of, there was a question which I'll probably, I'll throw this one to you, Matteo, and I think that I've seen a couple of questions which are along the same lines. So we'll see how we go. But the next question came through from Ronnie from the ACT. And it was, does it somewhere state in either an Australian standard or otherwise, or elsewhere, I suppose, how long a main switchboard should last?
Yeah, thanks, Ronnie, for the question. There is no specific clause in Australian standard that prescribes an exact lifespan for a main switchboard. The Australian standards focus more on safety, performance, and compliance rather than lifespan. These standards ensure that switchboards are designed and installed to withstand electrical, thermal, and mechanical stresses over time. Factors that significantly affect lifespan include, for example, environmental exposure, like, for example, coastal corrosion, dust, humidity, load evolution, installation quality, and maintenance practice. So while there's no fixed expired date for a switchboard, regular inspection and upgrades aligned with current standards are essential to ensure ongoing safety and reliability.
Matteo, just kind of, I'll keep you going. We had a question which came through live, which was like, how old a switchboard is suitable for looking at for the actual retrofit? Mr. The Hob said, we have something pushing 45 years old.
So yeah, thanks, Mr. De Hoop, for the question. In general, there is no strict age limit for when a switchboard becomes a candidate for retrofit. What really matters is its condition, criticality, and compliance with current safety and performance standards. That said, when you're looking at switchboards that are 40 or even 45 years old, like the ones you mentioned, you're definitely in the right zone to consider retrofitting. At that age, many components, especially circuit breakers, may no longer meet modern requirements for protection, coordination, or energy efficiency. Spare parts might be hard to find, and the original manufacturer may no longer support the product. Also, the insulation materials and mechanical parts could be degraded, even if the system still appears to function. So retrofitting in these cases offer a way to extend the life of the switchboard, improve safety, and bring performance up to modern standards without the cost and the disruption of a full replacement. And thanks to standardized testing like ISE 60947, we can ensure that the new components are fully compatible and reliable. So yes, a 45-year-old switchboard is not just suitable, but it's a prime candidate for retrofit, especially if it's still in operation and serving a critical function.
Awesome, thank you. Well, Mr. Dahob also had another question, which I might pose to you, Amir. It was, do you do on-premise monitoring, that is no cloud?
Yeah. Sorry, Megan, I lost you. So you are talking about the on-premises monitoring, all right? Did I catch it right?
Yes.
Yeah.
That's
So
correct.
yeah. So actually, from ABB side, we do have both options for the condition monitoring, either the on-premises or even the cloud-based monitoring. And fully, I understand most of the customers now, or most of the end users, are more preferable to the on-premises in order to ensure more cybersecurity, and maybe they are worried about cybersecurity. So from our side, from ABB, we have developed both solutions, the on-premises and the on-cloud condition monitoring system. And talking about the on-premises, we have developed our industrial gateway, which is almost, it's like an industrial PC inside your plant. So we are ensuring that all the data that we are collecting will stays within the plant, and it's having a data storage of 2 years, especially and it can be connected to 512 field devices. And for sure, if you are having a less quantity of 512 field devices, the storage can go more than 2 years. And in addition, we have developed a tailor-made dashboards in order to visualize all the data collected through this gateway. And for this pre-engineered or tailor-made dashboards, either you can review it on any web HMI, or it can be connected to the existing control system in the plant.
Awesome. Amir, I'll just keep going with yourself. There was a question which came through from Reese in New South Wales, and I think Danny in his intro, I suppose, did kind of highlight this, but his question was, how does an organisation know when it's time to modernise?
Okay, thanks, Reese. So actually, there is no fixed formula to determine when it's the right time to modernize the system, because we have seen a lot of installation performing well even after 30, 35, 40 years even, while other installations maybe require modernization after 20 years only. As a general rule, if a system includes obsolete components or have been in service for more than 30 years, so I believe it's a good practice, or it's recommended to start thinking about modernizing the existing installation. And here we can provide really a tailor-made evaluation which can help the customers to make informed decisions, balancing the investment on a long term and the reliability, safety, and the sustainability. And we usually help the customer to assess these factors and provide life cycle evaluation to determine the optimal modernization timing.
Just to add
Awesome.
there, Megan,
Perfect. Thanks, Deepak.
just to add for what Amir said, thanks, Amir. But another thing is, from a local organization, what we have in Australia, we can do a site visit for customer to estimate what is the operating conditions, what are the maintenance that has been done on the gear, to give us a proper overview of what factors to be considered in order to make a plan if retrofit or upgrade is required.
Thank you.
Thank you.
We had a question come through from Ryan in South Australia, which I thought was interesting. And it's, what is the expected lifetime of new modern switchgear compared to old CBs from the 1960s, which were well engineered and are still in service today? Maybe Amir might want to take that one.
Yeah. Okay, great. So thanks, Ryan. So typically any switchgear or circuit breaker are designed for the service life of at least 20 years. And within 30 years being the preferred targets, maybe, because usually customers are looking to extend the lifetime more than 20 or 30 years as well. So actual lifespan depend mainly on the environmental condition and the maintenance practices, and if there is any faults or short circuit or any impact has been exposed to the switchgear. And in many cases, especially outside the process intensive application, CB remains closed for a long time and may never experience any fault during this lifetime. As a result, it's not uncommon for circuit breaker to remain in service for over 50 years. But the real question is, what happens if a circuit breaker that have been in service for more than 50 years suddenly need an interrupt or suddenly face a short circuit? Can you be confident if it will maybe perform as expected, or maybe it could be better to have a modernized or an up-to-date breaker, which can you will be sure that it will sustain this fault.
Thanks, Amir. I'll ask you another question. So apologies, I've got a run of questions for you. This
No
one's
worries.
come in from Stefan in WA, and it was around the challenges. What challenges have you encountered while retrofitting new equipment? Space, especially offshore, is at a premium.
Yeah, it's a really good question because actually it's a typical for any marine or offshore plants that the space are not, there is a lot of limitation on the space. So actually we as ABB, we have supplied a lot of retrofit solutions in the marine and in offshore application, where really the space where we were having a space constraints. One of the main challenges in the environments is even ensuring compliance with the required standard and marine certification. Additionally, it's essential to have a qualified specialist authorized to work offshore and to ensure the necessary material are available for the intervention. You know, the logistics part for handling the material from the onshore to offshore, it's a challenge as well. And already we have addressed these challenges by offering the retrofit product compliant with the major marine registers and certification. Most of our engineers are certified to work on offshore operation plants. And our experienced project manager who can plan and mitigate the risks associated with the complex offshore installation. This comprehensive approach ensures that the seamless and safe execution of our retrofitting solution or installation of our retrofitting solution in the offshore plants.
Awesome, thank you. I've got a question which has come in live, and it's around the GIS PD monitoring. Very reliable. Is it very reliable and dependable now? So maybe I'm hoping someone would be able to answer that question. Deepak?
Yep, I can take that, Megan. Thanks.
Awesome. Thank you.
So as a part of our care portfolio and modernization portfolio, we are offering and we do on-site GIS PD monitoring. And this is really effective way for medium voltage switchgear to check what is the reliability and safety parameters if they are in line with the specification for which it was built. And this process of detecting and analyzing electrical discharges within the GIS equipment through PD monitoring is considered a very important part of our maintenance practice in ABB. So we see that as really a reliable tool for us in order to ascertain if the switchgear is complying with the design and the parameters for which it was built to function. So in short, yes, we definitely do that in ABB.
Awesome. Thank
you.
you. Matteo, I had, and we are getting to the end of the questions. Matteo, we had a question that came through, and it was how to take care of codal requirement compliance when retrofitting.
Yeah, from a product's perspective, it's important to highlight that all our retrofit kits are thoroughly tested in accordance to IEC 60947. This international standard ensures that the replacement circuit breaker not only matches but often exceeds the performance of the original device. We are talking about critical parameters such as braking capacity, thermal and dielectric behavior, and the mechanical endurance over time. When approaching a retrofit project, there are several key factors to keep in mind to ensure everything is done properly and safely. First, the new breaker must be capable of handling the same electrical stresses as the one it's replacing. This is where ISE 60947 testing plays a vital role. It gives us the confidence that the performance is aligned with the original specification. Mechanical compatibility is another essential aspect. The retrofit kit needs to integrate seamlessly into the existing switchboard without compromising insulation distances, accessibility, or safety clearances. It's not just about fitting the new device physically and mechanically, it's about maintaining the integrity of the entire system. Functionality also needs to be preserved or even enhanced. The retrofit should support all protection functions, coordination, and selectivity, and it must work smoothly with auxiliary devices and control circuits. This ensures that the system continues to operate reliably and safely after the upgrade. Clear and complete documentation is fundamental. Providing test reports, installation guidelines, and performance data helps ensure traceability and supports future audits or maintenance activities. And finally, the installation itself must be carried out by qualified personnels who understand both the legacy system and the new components. Their expertise is crucial to ensuring that the retrofit is executed safely and in full compliance with standards. So while regulatory compliance is certainly important, what truly guarantees the safety and reliability of a retrofit is the product level conformity validated through rigorous ISE 60947 testing. This is what allows us to confidently say that the retrofit solution maintains the performance of the switchboard.
Thank you, Matteo. Well, look, I think we've actually run out of time with our Q&A today. What I will do, though, and I really haven't briefed the speakers on this one, but just maybe a final comment that you would like to leave with the audience. And I might start with, oh, goodness. I'll start with you, Matteo, and then I'll just work my way around. So just final comment for our audience today.
Yeah, for sure. As a final comment, let's remark the key aspects of our retrofit kits. So for sure, sustainability, compliance to the latest standards, and a real focus on the simplicity of the installation of our products, because we are putting a lot of effort in order to develop a simple solution that can substitute in a simple way the old equipment.
Awesome. Thank you, Matteo. Deepak.
Thank you, Megan. One comment from my side would be our strong local presence and know-how of Australia and customers here is certainly what drives us to develop new solutions and further localize the retrofit kits and upgrades solutions to the market. And we are locally present. The customers and people can reach out to us for further discussion and to create awareness about the solutions. So it's an opportunity for us to assist our customers in the best possible way. Thank you.
Awesome. Amir, final comment.
Yeah, thanks, Megan. So I believe my final comment is that continuity of power is really something really needed and crucial for all of our customers. And it's not only maybe the modernization that we can offer. After maybe having like an asset review along with our customer, we can offer some other even solutions like stocking some spare parts, having some or having some other changing the maintenance strategy that the customer are having. So it's not only about modernizing, but it's all about that how we can advise the customer the right approach in order to maintain the continuity of power in their plants. So I would heavily recommend that the customer maybe can reach out to our EPD organization in Australia in order to engage with them and have the proper solution for their installation.
Awesome. Thank you all. And look, thank you all so much. That's all the time that we have for today. So please join me in once again thanking Davide Montefano, Matteo Aroldi, Danny Ma, Amir Abbas, and Deepak Thakur for their time and input. I would like to thank Engineers Australia's industry partner for our partner, ABB, I should say, for their support today. And if you don't mind, as always, if you could please complete the short feedback form, which is linked in the description box below. I say this all the time, but if you really could complete that, it does help us to improve and plan future sessions for you. Thank you again for joining us this afternoon, and we hope to see you at our next Industry Partners event. Good afternoon.